Hello students, it's Mr. Win here. Welcome to another tutorial video using IXL. And today we're going to be solving for a right triangle. What does that mean? Um, Solving for a right triangle means looking for all the missing parts of a right triangle. So whether it's the sides or the angles, so we'll be looking for all the parts, okay? Using the given information, of course. So let's take a look at this first right triangle. We have a right triangle, and one of the angles, one of the acute angles is given to us, and then the hypotenuse is given to us. So, well, if we and we're supposed to find the two legs, QR and QS, and then angle R. You can find anything first. Find the side first or the angle first. The easiest one to do here is the angle R. Well, since angle S is 45 and this is a right triangle, so angle R must also be 45 degrees. So what I'm going to do is I'm going to type in 45 there for angle R, okay, because it's 45, 45, and then 90. Um, well, that means this is a special right triangle. So if it is a special right triangle, let's review that real quick. If it's a special right triangle, you have shortcuts, and then you can use the shortcuts to find the missing sides fairly quickly. Let's review the special right triangle really quick. So you have 45, 45 here. That means the legs are going to be AA, and then the hypotenuse is A square root of 2, right? So in this case, we have the leg here, which is A, and then the leg here is it's also A, right? And then the hypotenuse here is actually A root, A root 2. Well, because the square root of 2 is already there, which means A has to be 6, right? So I'm gonna say that the legs are gonna be 6 and 6. So I'm gonna do 6 and 6. Now, because this is a special right triangle, we could use the rules of special right triangle and find the missing size fairly quickly. If it is not a special right triangle, then we'll have to use the trig ratios to find that. So I'm pretty sure they're going to come up later. All right, let's submit this. All right, let's take a look at this one. This one we have a 30 degrees, so that means the other angle has to be 60. So I'm going to type in 60 right here. And the hypotenuse is given to us. Now let's remind ourselves the 30-60 special right triangle is labeled short leg is A, long leg is A root 3, and then the hypotenuse is 2A, right? So let's keep that in mind. So what I have here is this is A, that's A, and this is A root 3, right? A root 3. And the hypotenuse is 2A. And the hypotenuse is what's given me. So right now I have an equation, right? I have 2a equals to 4 root 5. Okay, 4 root 5. So what I'm going to do is I'm going to divide by 2 on both sides. Well, if I divide by 2 on both sides, 4 divided by 2 would give me 2. So a would be 2 root 5, all right? And then my long leg, a root 3, legs, that's Q, right? So SQ would be 2, 2, root 5, that's A, and then times root 3. Well, oh, sorry, I can't type. And then, so root 5 and root 3 multiplied to give you root 15. So this turned out to be root 15. So my short leg is going to be 2 root 5. That is QR. So I'm going to type in 2. Oops, I can't type using that. So I'm going to type in 2 root 5 here. 2 root 5. And then my long leg, the long leg QS is going to be 2 root 15. All right, so 2 root 15. Okay, it's just a matter of substituting in the A once you found it. So hit submit. Yeah. Okay, let's delete what we just did. Okay. Solve for right triangle for this one. Oh, we have another 45, 45 right triangle. So I know angle A is now 45. And I know this is A root 2. Well, if this is A root 2, then A has to be 9, right? It's A root 2. The root 2 cancel. So A has to be 9. So I'm going to say, oh, this one's easy. So I'm going to say 9 and 9 for both legs. 9 and 9. Oops, that's not 9. Okay, so submit. Yay. Okay. Delete what I just typed in there. Oh, well, I shouldn't have. Well, I put back. There you go. A root 2. Root 2 matches again. So the sides have to be 2, right? Root 2 cancel. So A is 2. So the angle is 45 because it's a special right triangle, 45, 45. And then this is 2 and 2. All right. These problems are repeating itself. So I might have to skip jump level a little bit just to make the video short. Okay, let's say this is a special right triangle with I'll do one more 30-60, okay? I'll do one more 30-60. So in this case, the short leg is given to us, that's A. Now I know the angle is 30. If you want to go ahead and type in 30 for the angle, because we already have a 60, so the other one must be 30. All right, going back to labeling the sides here, this is going to be A root 3. Okay. And this is 2A. Okay, so A is 46, root 46, I mean, and then 2A would equal to 2 times root 46, right? So that's WX. So I think I'm going to type that first. I'm going to type WX in first. That's my hypotenuse here. So if I take for root 46 and I substitute it in for A, it would be 2 and then square root 46. Okay, so that's my hypotenuse. Now let's work on the long leg. The long leg is A root 3, right? Well, I know what A is. A is root 46. And then now I multiply by root 3 again. So what's 46 times 3? So you got a calculator. Do 46 times 3. 138. So the square root of 138, I'm not sure if that's simplifiable. So let me do 138 divided by x squared to see if I can simplify this square root, right? So go to second table and then scroll up, I guess, looking for y value. Oh, I'm going to reset my table to 0. Table set, where's table set? There you go. To start at 0. Okay. Second table again. My table start at 0 now. Now I'm going to be looking for a small y. Okay, there's no. So I know I can't find any y values that are whole numbers, smallest whole numbers. So I'm gonna have to say that 138 is simplified. Okay, so I'm gonna go back over here and say the long leg would be square root of 138. Square root of 138. Okay, because I couldn't simplify that. Submit. Yeah. Okay. Next one. Let's say this is a small another special right. So I'm gonna jump level because I want to show you the ones that are in special right, special right triangles, so that we could actually solve them right using trig ratios and inverse. So here we go. All right. So this time we're looking for um, two angles and one hypotenuse. Well, the hypotenuse is easy to do. We could do a squared plus b squared um, equals c squared, and then take the square roots, right? So what you could do is you could actually do 8 square, 8 square. So we do 8 square plus a root 3 square. I'm going to take everything and put it in parentheses. A square root of 3. And then I'm going to get out of there, close the parenthesis, square that, okay, enter, and that's 256. But then I have to take the square root of that. So I'm going to take square root of 256. It's going to be a very nice number. 256, enter. 16. So I know my hypotenuse UT or TU is 16. All right, that took care of the side. Now the angles, I don't know. So the angle is, remember when you're doing trig inverse, that's we use trig inverse to find the angle, right? So let's look at angle T first, okay? Angle T. Angle T, look at the two sides that are given to us. Or actually we could use the hypotenuse because we know the hypotenuse now is 16, right? If you don't want to deal with the root 3, leave it alone. Deal with the 16. I think this is a right triangle. But I'm going to use trig to show you if you use trigonometry, you could solve any right triangles. It doesn't have to be special or non-special. Any of them will work. Anyway, so I know this is 16, so I'm going to use adjacent and hypotenuse to solve this. If you're doing adjacent and hypotenuse, I mean you're doing inverse of cosine, right? So what I'm going to do is I'm going to hit second cosine. That will give me the inverse, right? And then I'll put in the ratio. The ratio is for angle T is adjacent over hypotenuse. So it's 8 divided by 16. And you're going to see it's one of the special right triangle. Oh, by the way, you've got to make sure you're working in degree mode. Move over to degree, enter. So go to mode, go to degree, and select that. And in second, quit to get out. And now you can hit enter. Look, it's 60 degrees. See? Angle T is 60 degree, which means the other angle has to be 30, right? So angle T is 60 degree. The other angle has to be 30, subtracting it from 90. And there we are. Okay, take that away. Okay, a root 5 and a root 15, and then I look for the angle. I don't know what's going on. So let's find the hypotenuse first. The hypotenuse would be a squared plus b squared equals c squared, and then take the square root, right? So I'm going to do a squared. Now, because it has a square root, I'm going to be careful and put everything in parentheses. So a square root of 15. Now make sure you get out of the radical, close the parentheses, square, and then plus, do it again for a root 5. So a square root 5, get out of the radical, close, square, and then enter. 1280. So now I'm going to square root that. 1280. Let's hope that it's going to be a nice number. Nope, it's not. So we have to simplify this, right? So I'm going to go to y equals and type that in. 1280, 1280 divided by x squared. X squared. And then I'll go to my table and I'm going to look at my answers. So as you can see, now what you want to do is you want to look on the y column and look for the smallest whole number possible. 20 so far. Anything smaller than that? Or 5. Oh, look at that. Okay. So 16 root 5 is the simplified version of 1280, right? So the ED is 16 root 5. That's what I'm going to type in. ED is 16 root square root of 5. All right. Now let's find the angle. Well, I have 16 root 5 that I already found here. 16 root 5. That's the answer for the hypotenuse. Which I could use the hypotenuse if I want to. I don't have to. Let's look at angle E real quick. If you want to use the hypotenuse, you can. But if you don't, you have opposite over adjacent, which means you could use tangent inverse, right? You could use tangent inverse. Because tan inverse is adjacent over, opposite over adjacent. Opposite over adjacent. And you have opposite and you have adjacent, so you could actually use that. So let's do that. Let's do the tangent inverse of a root 5 over a root 15. And of course, we're going to need a calculator to do that. We can do this by hand, guys. Okay, so remember to hit second and then tangent. That will give you the inverse. And then all you have to do is type in a root 5, a square root of 5 on top. Okay, make sure you get all the way out. And then now you're going to divide by 8 root 15. 8 square root of 15. Square root 15. Now, I'm not sure if I'm typing this in correctly, guys. Um, I'm going to test both versions to see if this is correct, right? So what I'm going to do is, if you notice, I don't have enough parentheses to cover the top and the bottom, but I wonder if it's the same. That cannot be it. That angle cannot be 83 something degrees. So that must be something wrong. So here's how you should type it. So tangent inverse. Put another set of parentheses for the top number, a root 5. A root 5. Close that one, or actually get out first and then close. Delete that. Get out of there and then close. That's just the numerator. Now you're going to divide by another set of parentheses, which is the denominator, a root 15. So I think this is the way to type it into your calculator. Okay, now get out. You're going to close the parentheses twice, right? Because one for the numerator, denominator, and then one for the whole thing. And then hit enter. And there's our answer. So 30 degrees for angle E. Okay, so I'm going to go back. Oh, it is a special right triangle. Angle E is 30 degree. Let's type that in. 30 degrees. All of these are special. And then the other one must be 60. Okay, submit. There we are. Delete that. Oh God, this is a 45, 45. How do I know that? Because look at that, equal, equal. So that's easy. That's 45 degree, 45 degree. See, knowing your special right triangle helps because it's shortcuts, right? And it makes the problem go faster. Now, AB though is 2 root 2. I mean, A root 2. A root 2. What am I saying? A root 2. Well, A is already have a square root of 7 in there. So if I replace A, I have to type in 2 root 7, right? And then the formula already has root 2 in it. So there you go. That's how it's going to work. So 2 root 7 times root 2. Well, root 7 times root 2 is root 14. So AB will be 2 root 14. So I'm going to type that in. Okay? So AB is going to be 2 square root 14. And then we're going to hit submit and we'll see. Ta-da! Brilliant. Okay, good. Okay, for this one, I have the hypotenuse and I have the leg. So I'm going to look for the other leg, which means I'm going to be subtracting, right? So I'm going to do Pythagorean theorem, but subtracting. So I'm going to do a root 2 square. So remember, put a root 2 in its own parentheses, a root 2. Get out of the radical, close the parentheses, square. That will ensure you squaring the 8 and you're squaring the square root of 2. So you're technically doing 64 times 2, basically. But I just want to type everything in like that so to let you see. And then do the second one. Oh, I'm not adding, I'm subtracting because I'm looking for the legs, okay? Subtracting 4 square root of 6. Square root, oh, I didn't put that in parentheses. I got to put the 4 root 6 in its own parentheses as well. So 4 and then square root of 6. Get out of the radical and then square. Okay, so that's how you do, that's how you find the leg. And then, of course, you have to take the square root after that. So square root of 32. You can simplify square root of 32. If you don't know how to do it right off the top of your head, you can go to y equals, type in 32 divided by x square, actually, because we're looking for perfect square. And then go to your table, second graph, and then scroll up a little bit because I went down earlier. Scroll up a little bit. Oh, look. 4 root 2. There you go. Always remember, look for the small whole value on your y, right? So 4 root 2 is the answer for the short leg. I'm going to go back over here and type in 4 square root 2. Okay. For the angles, you have, let's say if I'm working on angle X first. Now notice angle X, opposite of angle X is 4 root 6, and then the hypotenuse is 4 root 2. So I'm technically doing, because I'm doing opposite over hypotenuse, that would be sine inverse, right? So I'm going to do sine inverse on my calculator, okay? All right, let's get out of there. I'm going to do sine inverse of this opposite over hypotenuse. So sine inverse, second sine. All right, I'm going to do two sets of parentheses separately for the top and for the bottom. So I'm going to do one set of parentheses here, and I'm going to do opposite, which is 4 root 6. So 4 and then square root of 6. I'm just being very careful here, guys, when I'm typing this into my calculator. So you see that's the separate numerator there. Then I'm going to divide by another separate set of parentheses for the denominator, which is the hypotenuse, a root 2. So a square root of 2. And then make sure you get out of there, close the parentheses. So when I close that parentheses, it's just for the denominator. I got to close it one more time because that's for the whole thing, right? So how many ever you open is how many you have to close, okay? Hit enter. I gave you, it's a special right triangle. So angle X is 60 degrees. I'm going to type in 60, which means the other angle is 30. 30. Okay. Ta-da. Okay. Okay. I'm pretty sure these are all special right, but let me do this one real quick. Oh, this is not special right. You know why? Because that's 24 degrees. If that angle is 24 degrees, then you can find the third angle, right? Find the third angle right away. Take 90 and subtract 24, right? 90, take away 24. I will give you the other angle. Oops, that's not 90. 90 minus 24, okay? Should be 66. 66. All right, so angle 66 degrees for angle E. Now, look at what you're given. You're given an angle G and the hypotenuse. If you're looking for EF, EF would be, um, my reference angle is 24. So EF would be the opposite, right? Opposite. And then this is hypotenuse. So I have opposite and I have hypotenuse. That means to find EF, I can do sine, right? So I do sine of that angle 24 degrees equals opposite, which is EF, divided by hypotenuse, which is 10. And then I'll do my cross product, right? My cross product would give me EF equals to EF times 1, which is EF. So EF would equal to 10 times sine 24 degrees. Okay, so you can actually type this into your calculator and it will give you an approximation of EF, how long segment EF is. And according to the direction, we can actually round it to the nearest 10, which is 1 decimal. So let's type this in. 10 and then sine 24 degrees. Okay, 10 times sine of 24. And the thing is, you don't actually have to put times, right? The calculator actually understands that. So hit enter. And again, we have to make sure we're in degree mode, right? So the opposite side is 4.067. Now to round this to the 10th, which is one place, you have to bump up this 6 to a 1 right here, or the 0 go up to a 1 because the 6 is higher than a 5. So I'm going to put in 4.1 for EF, okay? 4.1 for EF. 4.1. And then to find FG, FG is actually adjacent, correct? So FG is adjacent. So I can do adjacent over hypotenuse. So in this case, I'm going to be using cosine of 24, okay, equal GF divided by 10. And again, it's the same thing again. So GF, to find GF, you would do 10 times cosine of 24 because the function now is adjacent over hypotenuse. So you could actually go back to your calculator, recall this, and actually change this to cosine, right? Change this to cosine. So 10 times cosine of 24, that would give you GF, okay? So it's 9.1. I'm gonna go back and type in 9.1, and I'm gonna cross my finger that it's gonna take my answer as correct. Yay! All right. Delete what I just did there. Okay. 23 degrees and 7. So they're giving me 23 and 7. Well, 23, if you do 90 minus 23, it should end up you with 67 as the other angle, right? 67 plus 23 is 90. To find HG, I'm going to do the opposite first, right? HG is opposite because my angle is 23. So opposite. And this one is my hypotenuse, okay? And this one is my adjacent. All right, to find HG, I have opposite over adjacent. I have to use 7, otherwise I can't solve this, right? So opposite over adjacent, opposite over adjacent. Do you remember what function that is? It's actually tangent, right? So I'm going to do tangent of 23 degrees equal to opposite, which is HG, divided by 7. So if I were to solve for this, I would cross multiply, right? So tangent times 7, or tangent of 23 times 7. So to your calculator, do tangent of 23 close to parentheses times 7. Or you could put the 7 in front and then you don't have to multiply, worry about the multiplication sign. 2.97. So that's almost 3. I'm gonna put it in as a 3, okay? So HG is the one I just found, is 3 units long. Now, I think using Pythagorean theorem would actually be faster here. To find the hypotenuse, I do 7 squared plus 3 squared, right? 7 squared plus 3 squared. And then I have to take the square root of that, and then I can round it, 58. You could use a trig ratio, but it probably will take us longer. So using Pythagorean theorem is a little bit faster. So 7.6, because I now have two sides, right? What was my answer? 7.6, okay? 7.6. So let's see. Yay, okay, that's correct. Perfect. Okay, we're at 81. I want to skip again just to get to the challenge zone, okay? We've seen that type of problem. So let's skip again to the challenge zone. All right, so here's the challenge zone. We have, oh, it's just decimal. So we are given two legs. We're supposed to find the hypotenuse. That's easy. Go do your Pythagorean theorem. 7.4 square, okay, plus 5.3 square. Okay, enter. And then we're going to take the square root of that. Square root of, that's too many numbers, so I'm just going to put square root of the answer. And then it's going to be 9.1. So I'm going to put 9.1 in here for the hypotenuse. To find the angles, remember we have to use inverse, right? So to find angles, say let's say we're going to do angle C first. If we do angle C, then this is actually the opposite. Right? This is adjacent. If we're doing angle C, correct? So which one has opposite over adjacent? It's tangent. Tangent has opposite over adjacent, right? So I'm going to do tangent of the inverse. Okay, so I'm going to do, because we're looking for the angles. That's why I'm doing tangent inverse. And then I'm going to do opposite over adjacent. So 5.3. Oops, I didn't put the point there. 5.3 divide by, I don't need special parentheses because this is just a decimal value or a number. 7.4, close the parentheses, enter. So the angle is about 35.6 degrees, rounding to the 10th place, so 35.6. 35, have to get out of there, 35.6. 35.6. All right, now to find the other angle, all you have to do is subtract it from 90 degrees. So I'm going to do 90 minus that answer that I just found. to give me the other angle, which is 54.4. 54.4. 54.4. Submit. There we go. Brilliant. Okay. Next one, we have with the leg, right? So we're going to be subtracting 6.5 square minus 5.5 square. And I'm going to go ahead and type in the parentheses at the square root so that I don't have to square root later. So 6.5 square minus 5.5 square. 5.5 square. Okay? And enter. So the answer is 3.5. I got to round that 6 up. So 3.5. 3.5. For the angle, now notice if I'm looking for angle, let's say B. Let's say if I look for B first, then 5.5, it's my opposite side, right? And then 6.5, of course, is my hypotenuse. That doesn't change. So the function that does opposite over hypotenuse is a sine function. So, but I'm looking for the angle, so I'm going to be doing inverse sine. So second sine will give me the inverse, and then opposite over hypotenuse, which is 5.5, 5.5 divided by 6.5, 6.5. And then close the parentheses, hit enter. So the angle B is 57.8 degrees. So I'm going to round that up. 57.8. So 57.8. Then I take 90 and I subtract that, right? So 90 minus the answer, minus that answer, will give me the other angle, 32.2. So I'm going to type in 32.2. Okay. Very cool. 94 points. I'd like to take you all the way to 100, but I think at this point, you understand what to do. Remember to find the size, you can use either the trig ratios or the Pythagorean theorem. But in order to use Pythagorean theorem, you have to have two sides. To find the angle, you have to use the inverse. Okay. So I hope that was helpful. If you have any question at all, just email me, and I will be sure to answer your questions. Okay. Thank you for watching, guys. I will see you next time. Bye bye.